Welcome back. At this time, we're supposed to get right straight into the order of operations and the properties of numbers. I've got a little section I need to introduce to you right at this moment. It's called corrections and amplifications. That is the point at which I try to go back and re-explain something because I didn't explain it well enough, at least I didn't think I did, or to outright fix something. So right now we're going to fix something real quickly. In the previous video, I mentioned to you that this x minus 5 is a term. Well, technically, that's not true. The term here, there are actually two terms. So when you go back and look at what is a term, this negative 5 is a term. It's a constant number, which is a term. And this x is a term, which is a simple variable. So quick correction that when you go back and you see in our video something like 2x plus 6, this is technically an expression with two terms. And the two terms in this case, once again, is positive 6 is one term, and 2x is another term. So let's just get that correction in place before we move on. So now we're going to talk about the order of operations. The order of operations has two pieces to it, and there was one piece that's actually bigger, and we want to just separate them out real quickly, and that is the order of operations fall under something we call the properties of numbers. Remember again, for my pre-algebra students, this is really important stuff that you're learning, but for my algebra students, this may not be something new to you. You should have seen this in pre-algebra had you done a pre-algebra class. Let's start with the order of operations, and then we will go into the properties of numbers. The order of operations, for those of you who may remember from your 6th grade class, you may have remembered learning something like this. PEMDAS. PEMDAS, we explained to students back in the 5th and 6th grade, something like, please excuse my dear Aunt Sally. That is very important because whenever we're going to simplify an expression, or if we're going to evaluate an expression, there is a certain order of things that we have to do in order to be correct. If we do not follow the rules of PEMDAS, what's going to end up happening is we're going to come up with a wrong answer. And for that reason, we need to explain PEMDAS. PEMDAS means if I see an expression, I'm going to give you an example, an expression 2 times the quantity 5 plus 7 minus 4 times the quantity 8 divided by 4. That looks like a kind of an ominous expression, but if we don't do this correctly in the correct order, we're likely to end up with, or we will end up with, an incorrect answer. So, the first piece is whenever I have an expression that has parentheses around it, I must do my parentheses first. First do parentheses. Therefore, I'm going to come in here. The first thing I'm going to fix is what's inside of parentheses, and that is 5 plus 7. 5 plus 7 is 12, and this becomes 2 times 12 minus, what happens here next is 4 times 8 divided by 4 is 2. So my parentheses are gone. That's the P in PEMDAS. The next thing I must do on my E, which would be any kind of exponent, such as 3 squared. In this case, I have no exponents, so I move right on to the next thing. The next thing is multiplications and divisions, which are multiplications and divisions. We have to get those out of the way. Multiplications and divisions. Now, I have already done one of my divisions, but that was done because it was in parentheses. Let me fix my parentheses here. That was in parentheses, so that's why it got done earlier. So now I'm going to do my multiplications and divisions, and my multiplications would be 2 times 12 is 24, minus my next multiplication, 4 times 2 is 8. So I've now done my parentheses. I had no exponents, my multiplications for M, my divisions for D, and I'm now left with my A and S, which is A for addition, S for subtractions. And that's the order of operations. I have no additions to do here, just a subtraction, and 24 minus 8 would give me 16. 24 minus 8 would be equal to 16. And notice what I do here. I box or circle my final answer. Remember, that's one of the rules we learned 2 videos ago, that whenever you come up with an answer to a problem in mathematics, your teacher or your professor, when you get to the college level, expects you to box or circle your final answer. So that is the explanation for the order of operations called PEMDAS. There are some other pieces to the order of operations that we must get a handle on, and that is what we call the properties of numbers. This is the heart and soul of algebra. The properties of numbers mean I should be able to move things around, and whenever I move numbers around, they either A, change my values, or B, they don't change my values. Here are some of the things that you need to know about the properties of numbers. The first thing you need to learn is the commutative property. Commutative property is either of additions or multiplications. It's quite simple. Commutative properties of addition simply means 5 plus 4 is the same as 4 plus 5. That's called the commutative property of addition. So 5 plus 4 is 9. It's equal to 4 plus 5 is 9. That, once again, is the commutative property of addition. The commutative property of multiplication is just as easy. If I have 2 times 4, that is equal to 4 times 2. 2 times 4 is exactly the same as 4 times 2. 2 times 4 is 8. 8 is equal to 4 times 2, 8. It's called the commutative property of addition and multiplication. The next thing, or before we even go on, remember commutative properties do not work with subtraction, because in the case of commutative properties, 5 minus 4 is not equal to 4 minus 5. 5 minus 4 is 1. That is not equal to 4 minus 5. 4 minus 5 is equal to, and in this case it's not equal to, negative 1. This is how we know that commutative properties do not function with subtractions. They only function with additions and multiplications. I'm going to write this one more time so everybody knows. Commutative properties work only with additions and multiplications. Other than that, commutative properties will not work. Next, we talk about this thing called the distributive property. Distributive property, I need to explain. Distributive properties of numbers run like this. 3 times the quantity 4. Oops, I must have been thinking about something else. Let's go again. 3 times the quantity 4 plus 2. 3 times the quantity 4 plus 2. According to distributive property, rather than going through the long PEMDAS thing, I can distribute the 3 to both the 4 and the 2. So 3 times 4 is equal to 12 plus, because I bring this down, 3 times 2 is 6 equals 18. Distributive property means I'm going to distribute the number from outside the parentheses to everything inside of the parentheses. Please understand, distributive properties also works with negative numbers. Distributive properties, for example, if I have 4 times 8 minus 2, I'm going to distribute my 4 to my 8 and distribute my 4 to my negative 2. So here we go. 4 times 8 is 32. 4 times negative 2 is negative 8. 32 minus 8 equals 24. So distributive properties work with negative and positive numbers. After distributive properties, the next type of property of numbers we're going to look at is called identity. Identity property is the use of ones and zeros with any existing numbers. For example, identity property of adding 0. 5 plus 0 equals 0. That is called the identity property of adding 0. That, by the way, is true of subtracting 0. The identity of adding and subtracting 0. 5 minus 0 equals 5. Now I better go back and fix. 5 plus 0 is not 0 for anybody who's paying attention. It is actually 5. 5 plus 0 is 5. 5 minus 0 is also 5. Just checking to make sure you're paying attention. The next thing we look at is the identity property of multiplying by 1. That is, 5 times 1 is equal to 5. 5 times 1 is equal to 5. That's the identity property of adding 1. These become important, by the way, because as we get to more advanced algebra, these are going to be the kinds of things that we don't even think about anymore. So we learn them now, get them out of the way, so later on we don't even have to think about them before we do them next. And the next identity property is the identity property of times 0. That is, 5 times 0 is equal to 0. That is the identity property of times 0. So once you get down into doing your deeper algebra and you find that you multiply a number times 0, you're not even going to go through the multiplication process anymore. You'll simply use the axiom called the identity property of 0 and make sure that that comes out to 0. Next up on our list is what we call the associative property. The associative property is a little bit different. That tells me if I have, I'm going to give you the letters first and then use the numbers. A plus the quantity B plus C. Associative property tells me this is equal to, it is just the same as if I wrote B plus the quantity A plus C. Now let's work this out using numbers to make sure that our understanding of the associative property is correct. If I have 2 plus the quantity 3 plus 4, that, according to the associative property, should be equal to if I flip any of these, i.e., if I say 3 plus the quantity 2 plus 4. Let's check this out and see if it works. So 2 plus the quantity 3 plus 4, 3 plus 4 is 7, 7 plus 2 is 9. Is 9 equal to 3 plus 4 plus 2 is 8, 4 plus 2 is 6, my bad. 4 plus 2 is 6, plus 3 is equal to 9. Now I can take these numbers, 2, 3, 4, and I can move any one of them wherever I want. For that matter, I could have gone with saying 4 plus the quantity 2 plus 3. And that would be exactly the same as if I were to say, oh, let's pick any one of these two here, and it will work out exactly the same. This is called the associative properties of numbers. It's a very important part of algebra because once you get up into the geometry parts of algebra, this becomes very important where you begin to deal with equal sides or equal lengths or probably something such as equiangular properties of triangles and things of that sort. So that is associative property. And the last of the properties we're going to look at is called the inverse property. Inverse is quite simple. You've seen this before. Inverse property simply means this. A, I'm using letters now, A plus negative A is equal to 0. Let's put that into numbers format. If I have 7 plus negative 7, that gets me 0. That's going to get us to the place where we start doing equations, and we want to get rid of a 7. The way you get rid of a 7 is by adding a negative 7 to it. That's called the inverse property. There was one last piece to the inverse property I'm going to share with you, and that is where you use a fraction to get rid of a full whole number. If I have the number 2, for example, and I want to get rid of the number 2, what I can do is multiply the number 2 by 1 over 2. I multiply 2 times 1 over 2, and this is going to give me a 1. This becomes very important later on when we start to deal with equations. This is very simply explained. If I have a 2 times 1/2, technically what that is, it's 2 over 1. A whole number technically is that number over 1. Keep that in mind because it's going to be important in our next video where we get into equations. 2 over 1 times 1 over 2. Just do the same fraction multiplication that you learned to do back in 5th and 6th grade. 2 times 1 is 2 over 1 times 2 is 2 equal 1. And there you have it, how we explain the inverse properties. That's it for the properties of numbers. The next thing we're going to start looking at is equations. We're looking at solving them and solving the simple single step, the double step or two step, or the multi-step equations, and also equations with fractions. That's our next video. It's very important, so please look for that coming up next, and I'll see you on the next side of this.